The OSI model, the Open Systems Interconnectivity or Interconnection model, is going to really be useful for you after you watch this live lesson on the topic. It is not just going to be some abstract model that requires you to memorize a bunch of weird stuff. We're going to explain to you exactly why this model exists and how incredibly powerful this model can be for you to understand, implement, and perhaps most importantly, troubleshoot modern network infrastructures. I hope you'll join me for this module, very, very important module, where we're going to look at this particular OSI model. We'll master it, but most importantly, we'll see how it can really be of assistance to us as modern day networking engineers. Hello everyone and welcome. My name is Anthony Sequeira with StormwindLive.com, and this is our Network Plus Video Mentor Series, compliments of Pearson IT certification. In this series of videos, we're going to explore the most important, the most critical, the most fascinating areas of modern networking technologies. We're going to go ahead and get started in our first video here with a look at two very important network models. It's great that we are starting this way because we'll be referencing these particular network models as we move throughout all of these videos. By the way, in these videos, we'll be doing hands-on demonstrations of key networking technologies. So this will be very, very important to complement perhaps reading that you're doing in the area of Network Plus. We hope to really bring these technologies to life for you in these videos. And you'll see that this first video, although it's going to be a lot about theory and conceptual networking models, we'll even dig our hands in to some key networking technologies at live demonstration throughout the course. Well, let's get started as we take a look at two very important reference models. The OSI model and the TCPIP model are really going to be critical foundations for us to understand as we look at particular technologies. Now, one of the questions students often ask me here is, why? Why are we burdened with mastering these particular models? And the answer is, it can really assist you when it comes time to troubleshooting and comprehending what's going on in a complex network technology type environment. You might wonder, why were these models invented in the first place? Well, they knew that it would be easier to teach someone about networking and for someone to learn complex networking if they had a reference model, but it wasn't just that. You see, when network systems were first implemented by particular networking equipment vendors, they were each following particular proprietary methodologies. There was no standardization, so what happened was you would have to invest basically in just one vendor's equipment because that vendor's equipment couldn't interoperate with the equipment from other networking vendors. We had what were called proprietary systems that were being developed. The OSI model was designed so that there could be an ease of standardization when it came to networking equipment. And we could have the equipment from one vendor easily interoperate with the equipment from other vendors. So this was a key catalyst in the development of this OSI model. Today, we really get to take advantage of this, don't we? We know in the area of wireless networking, for example, there's the Wi-Fi Alliance, whose job is to make sure that all of the different networking equipment can play nicely together. So we can go to one particular vendor for a wireless LAN client type of device to access the wireless LAN, and we can make sure this is going to interoperate perfectly with perhaps the creator of the access point that is making that wireless signal available to us. So the OSI model really makes sure we have that interoperability between these different vendors. The model itself is layered. And by having a simple layered model, it helps us to understand it. And as I said, when we do some troubleshooting together in this course, we will go ahead and be able to really conceptualize where the problem in the network might lie by looking at this layered model. Now, the first thing you need to do with this OSI model is you need to memorize it. We can go from the bottom up, or we can go from the top down in order to memorize it. There are two common mnemonic devices that are used to help students keep these layers and their exact order straight. You can go, please do not throw sausage pizza away, as a way to memorize the physical, data, network, transport, session, presentation, and application layers. Or you can use the clever mnemonic, all people seem to need data processing, to memorize it in that order. The application layer, the presentation layer, session, transport, network, data, and physical. Now, one thing that you're definitely going to want to do as well is make sure that you understand that we often refer to the bottom layers by their numbers. So you'll hear networking engineers say, oh, it's a layer 1 problem or a layer 2 problem, instead of saying a physical or data link layer problem. Oftentimes, as we refer to these four by their layer numbers, keep in mind that when it comes to the upper layers like 5, 6, and 7, we'll often kind of group those together and just say it's a higher level problem or an upper layer problem or simply an application layer problem when we're referring to those top 3 layers. So let's make sure we have a mastery of the model itself and that we can memorize physical, data, network, transport, session, presentation, and application as those particular layers. Now, when you take a look in detail at the physical layer, it's no surprise that this deals with the physical cabling, or in the case of a wireless local area network, the radio frequencies that are going to be carrying our data from one location in the network to another. So we have electrical, mechanical, procedural, and functional specifications here that are going to refer to our physical media for carrying the data. Remember, this does include wireless networking technologies, so it's not always that we can physically see or touch the media. It could be the case that we are utilizing the air, right? We are sending the data in radio frequencies that are moving, not visible to the eye, through the air. So pretty interesting how that physical layer also incorporates the radio frequencies of wireless LANs. Now, as you move up the OSI model, you'll see that the next layer is called the data link layer. Notice that here we're going to start to format data. Okay, the data is going to be formatted in such a way that it can be understood by the network layer above and by the physical layer down below. Notice also that it is the job of this data link layer to control access to the physical layer. And it's also the job of this data link layer to start implementing addressing. what we call layer 2 addressing in networking. As a matter of fact, I want you to memorize that here at layer 2, here at the data link layer, we are going to have in Ethernet networks, as we will see, we're going to have the first of our addressing for the network information that's being transmitted, and the addressing that we're going to use is called MAC addressing, Media Access Control addressing. Let's take a look at that right now at the command line, shall we? Or at the on a workstation. If we go and we bring up a command prompt on our Windows workstation, we can do IP config. This IP config utility we'll be using a lot throughout these videos in order to check the addressing information, network addressing information, that has been assigned to our particular workstation. Now, when we do our IP config here, we see that we've got all of this information about layer 3 addressing. We can see that we have an IPv4 address, a subnet mask, a default gateway. We'll be exploring those in great detail in later videos. And then we can see even IPv6 information that has been assigned to our device. But what about this layer 2 MAC address in this Ethernet network that I was telling you about? Well, in order to see that, we're going to have to use a variation of the IP config command. We're going to say IP config /all. The IP config /all command, as you can see, will give us even more details about this particular network device. And if we look up here at the output, we can see one of the details that we are getting for this network adapter is the physical address. Now, this is a Windows 7 presentation of this information, and notice that it's a little deceptive, isn't it? It's not an address at the physical layer of the OSI model. We know this MAC address is the address of this device at the data link layer, layer 2. I suppose Microsoft terms this the physical address because it is physically burned into, it is physically stamped into the network adapter that I have in this particular workstation. Notice this is an hexadecimal address. The MAC address is 48 bits in length, and it is represented in hexadecimal. Here in Windows 7, they choose to put dashes in between the hex fields. You could see this represented differently with periods between those fields, so just be ready to be flexible there. In some network device presentations, there is nothing. It's just the string of hex characters, so you'll see it presented all kinds of different ways. But folks, this is a key ingredient here in our story, isn't it? This is a layer 2 MAC address, and it's one of the important ingredients that we have in the implementation of the OSI model of that data link layer. Speaking of the OSI model, let's jump right back to it, and let's talk about the next layer, the network layer. This is a real famous layer, especially when it comes to folks like myself that are Cisco certified internetwork experts. We make a lot of our living here at the network layer. This is where we have our IP addressing. This is where we have our routing functions. So when we go and we look at that output of the IP config all, and we see things like our IPv4 address and our subnet mask and the address of our default gateway, this is all addressing information that is defined at layer 3, the network layer. Remember how I said this can really help us to troubleshoot this model? Well, one of the ways in which it can work is you can, when you start troubleshooting, you can choose to do what we call a bottom-up approach. If someone says, I cannot connect to the internet, you go to their workstation and you check the physical layer. Are they plugged in to the network? Then you check the data link layer. Are they, do they have their MAC address burned into the device? Are they connected to a layer 2 switch to access the network? Is the encapsulation and is the duplex mode set correctly? And then you can look at the network layer. You can do that IP config all command and make sure they're getting an appropriate IP address, subnet mask, default gateway, DNS assignments, all of that stuff that relates to the network layer. See how clever that is, folks? How we can go ahead and troubleshoot logically a layer at a time until we discover the problem. Speaking of our layers, the fourth layer of the OSI model is our transport layer. This is where we are going to decide for the particular network application that we are utilizing whether or not we want to send information reliably or unreliably. Now, I know what you're thinking. Why in the world, Anthony, would I ever want to send something unreliably in the network? Well, it may be that you want to send the network data with as little overhead as possible. And the protocol that we use at the transport layer for this is called User Datagram Protocol, or UDP. Perhaps you want to send the information with extreme reliability, and you don't care about the additional overhead that's going to be placed in the communications as a result of this. This is why we would use Transmission Control Protocol, or TCP. Most applications want the reliability, and that's why our TCPIP protocol suite got the name of TCP and IP. There's lots of other protocols that make up the suite, but those are so popular, IP at the network layer and TCP at the transport layer, that the protocol suite was named after them, TCP/IP. But folks, for right now, let's just make sure we're rock solid on the fact that at the transport layer, we do have two major decisions or options. Do we send the data reliably or unreliably? And we have TCP and UDP respectively in order to transport the information in those manners. As we move up the OSI model, we can see here we are at the session layer now, and sure enough, the session layer is going to handle managing the actual establishment and then the ongoing management and the termination of particular sessions that are set up between network applications, for example. The next layer, the presentation layer, deals with the formatting of data. Have you noticed how JPEGs are the most popular format these days for taking photographs and placing them in the internet or placing them in emails? That format of JPEG is an example of what the presentation layer deals with, making sure the data is formatted in such a way that our networking application can understand it. Finally, in our OSI model, we have the very top layer, the application layer, which presents networking services to the end user utilizing some kind of very friendly, very easy to use application. Like maybe we're using Microsoft Outlook as our email interface, or maybe we're using Google's Chrome browser as the web interface in order to interact with the network data. So the application layer is certainly where we have the most complexity and the most sophistication, and it's the layer that I interact with the least as a Cisco certified internetwork expert. Again, as I said, I am relegated to dealing with these bottom four layers as I design and troubleshoot Cisco networks. Now, by the way, that is not to say that the application layer isn't important and troubleshooting of the application layer isn't important, and that's not to say that Cisco doesn't get involved with application layer technologies, because they do. It's just that in my particular niche within Cisco networking, I find myself often working down here in these 4 lower layers. Now, understand that when you talk to someone about how this OSI model works, they're probably going to bring up the word encapsulation. In fact, they might even bring up the word de-encapsulation. What is this all about? Well, you see, when you compose an email, this email is composed up at the top application layer, right? And as that email in the form of data is handed down to the presentation layer, it will add additional information for the networking functions to that data. It hits the session layer, it adds information. It hits the transport layer, it adds information. It hits the network layer, it adds information. In fact, we already know that IP addressing information would be added there. It hits the data link layer, more information is added. We know MAC address information on an Ethernet network would be added. So you can see that as the data makes its way down the OSI stack, information is added so that the network devices can transport that data. And this is called encapsulating the data. We are adding information to it. A nice analogy about this would be like Federal Express or UPS. I take a letter and stick it in an envelope and just scrawl the name of the person on the outside of that. I then bring it to FedEx and they put it in another letter and add more addressing information on it. And then it goes into a truck or an airplane with more information on it in a bigger container. And this adding of information for transport is just like our encapsulation process here as we discuss the OSI model. Guess what? On a receiving machine, as the encapsulated information and data arrives, the encapsulated info is stripped off as it moves up the model, and this, of course, is what we call de-encapsulation. So please be familiar with encapsulation and de-encapsulation when it comes to the OSI model. Now, I told you that I tend to make my living down here at these lower 4 layers, and we like to go ahead and term the data and the encapsulated information. We like to go ahead and give it a special name down at these lower 4 layers. For instance, at the physical layer, we refer to them as simply bits, while at the data link layer, we call the data and the encapsulated information frames. And then at the network layer, the data and the encapsulated information we refer to as packets. And then finally, at the transport layer, we have the data and the encapsulated information, and we call it segments. To memorize this, I use the mnemonic, "Some people fear birthdays." And I want to thank a dear friend of mine, Darren Dennis, in this networking industry. He actually coined that particular naming strategy to remember it. Some people fear birthdays. Segments, packets, frames, and bits. Notice we call the data and the encapsulated information up at the top layers, we simply call it data when it's up there. I'm a stickler for this particular nomenclature, folks, and I ask my students to use it correctly. For instance, if they're troubleshooting a layer 2 switch at the data link layer, I like to hear them refer to frames entering that device and leaving that device. And if they're troubleshooting a layer 3 router at the network layer, I like to hear them talk about frames that are coming in and out of that device. So I'm a stickler when it comes to this particular nomenclature, and I think it's important to memorize this and use it correctly when you're in discussions about networking equipment. Well, folks, the OSI model, believe it or not, was not first. What predates the OSI model was an invention from the United States Department of Defense, and it's called the TCPIP model. Now, as you can see, the issue that we have with the TCPIP model is that it is not granular enough. They didn't break it down into enough layers. They had just one big application layer where they had all their application presentation and session functions defined. They did have a transport layer, just like we have in OSI, and they had an internet layer, which was renamed network layer in the OSI. And finally, they lumped the physical and data link properties together into just one layer called network interface. I think it's very important for us to go ahead and realize that we have this TCPIP model that predates the OSI, and we should understand how the layers map to the OSI model. Keep in mind that this certainly works, right? But when we have the more detailed OSI model, it typically gives us much more assistance when we are teaching networking to an individual or when we are troubleshooting a particular sophisticated network environment. Well, I hope you have loved this first video on important network models that we should master. We had our OSI model and our TCPIP model. We hope you're excited for the upcoming videos here in our Network Plus Video Mentor.